So in order to find the x and y intercepts, you put it in the calculator. These are clearly the x intercepts, there, there, and there. And we look for them here because they should have zeros for y. So where are they? This one, this one, this one, and this one. And then what is the y-intercept? You don't see it there, but how could you tell what the y-intercept is? Okay, I mean, you could just tell it's somewhere down pretty negative, which means it's going to be negative 12. But remember, when you're looking at a polynomial, which is in standard form like that, the constant is always the y-intercept. I mean, so there's really no work to do. It's negative 12, right? Because again, on the y-axis, x equals 0. Well, if x equals 0, then that term is 0, and that term is 0, and that term is 0, and y equals negative 12, right? That's why it is. How else could you check for the y-intercept then? Go to the table, right? Go to the table, and at x equals 0, y equals negative 12. There you go. Okay, so, and again, they said x-intercepts, but x-intercepts are also known as zeros. And when you're solving equations, they could be called roots, and they could be called solutions. Okay, how about this one? What was the end behavior? I mean, what do we mean by end behavior? Right, it means what's going on over here and over here. You know, is the graph going up? Is it going down? Well, this one, because it's got a b and a c as part of the expression, you can't really put it in the calculator like that. But you could say, what kind of function is it? It's quadratic, right? And it has a minus in front. So what do you know about the shape of the graph? It's flipped down. So it's a parabola that looks like this, right? And so what would you say the graph is doing as you go off towards the end? It is going down towards negative infinity. What is it doing on this side as you go towards the end? It's going down. So the answer was y approaches negative infinity. Done. Right? That's what you mean by end behavior. What's it doing as you go to the end of the x-axis on either side? Okay, the domain is all real numbers except which numbers? How do you find the domain of a rational function? It's all real numbers except what numbers? The zeros of the denominator, right? So in this one here, right, you would factor it. How does that factor? X minus 3, x plus 8. And so what values of x are going to make that denominator equal 0? 3 and negative 8. 3 and negative 8. How could you use your calculator to find this in this case? You could put it in the calculator, and then what would you see in the table of values? You would see errors. At negative 8 and 3, it would, in the y column, it would be error, because that's not in the domain. Okay, scatter plots. Did anybody come up with the value? Lee? I'm saying A, B, C, or D. Which one? B? Who's got C? Sandy, you got C? Anybody else follow it through? Who wants to vote for Sandy, and who wants to vote for Lee? Okay. Okay. Lee, what's going on? Sandy's right. The pressure. Okay. How do we make a scatter plot? Given data, how do you make a scatter plot? You got to enter the data first. How are you going to enter the data? Stat edit is the first one, right? And then so you're putting in all the x values going under L1 and all the y values go under L2. Okay, now, you should be ready at that step to look at the data and decide what kind of function you want to use. This problem, you don't have to, because they tell you what kind of function to use, right? They said use an exponential curve, right? So there's really no point in looking at it. If I wanted to look at it, how would I look at it? Yeah, the second y equals, and you turn on the plotting of points, right? So I would go 1, and then make sure that it's highlighted on. And then how do I make it zoom to the points that I just entered? It's zoom stat or zoom 9, right? So zoom 9. Okay, so there's points. That's a function we still have at y equals. Don't worry about that. So if you have to look at it and decide, then do that. Now, if I'm looking at that there, if I had to decide myself, I'm not sure I would have said I was going to use an exponential to graph that. You know, it looks like it could even be linear, or maybe it looks like there's a teeny little bit of a curve in there. Sometimes with that kind of function, you use a parabola, quadratic, and just have like one side of the parabola going through. But in any case, we don't have to decide that because they told us what kind of function to use. So how do I make the calculator model that data with an exponential function? Stat, arrow over to the calc, and then find exponential in that list. Where is it? 0, exponential regression, right? So go to the 0 one way or the other. There we go. Hit enter and hit enter. So y equals a times b to the x. A equals 1,000, b equals 1.06. So that looks, oh, I can't do that there because you wouldn't see it. So I'm going to write it like this. What is that? That's not what I wanted. Oh, I guess I can already write on that anyways. I didn't need to do that. So this is what it looks like according to that. Y equals 1,000 times 1.06 to the x. Right, that's the exponential curve of best fit. Now they said, which is closest to the expected amount of earnings you would have after 30 years? What are you expected to do? X equals 30. Plug in x equals 30. So what is 1,000 times 1.06 to the 30th? It's definitely not B, that's for sure. Let's see. Okay. So you need to remember how to do that. I mean, these kinds of things, I mean, a lot of the stuff we did so far is using a calculator kind of in a tricky way. This is the way we were supposed to know how to do this stuff, using the calculator. Okay. Okay, which one of these graphs represents the zeros, -2, -1, and 2? Okay. Right, so again, we've already kind of reviewed this concept in this set of problems, but the zeros are the x-intercepts. So which one? It's got to have 3, so it can't be this one and it can't be this one. But these are not the right values. These are -2, -1, and 2. And just to remind you, if these are the zeros, what are the linear factors? X plus 2 times x plus 1 times x minus 2. Okay, good to go. So I'm going to review, these are the things that we have not done yet, right? We have not done sequence and series, and we have not done variations. We're going to do those today, and I'll assign homework related to that. We also have to go back and do the permutations and combinations and the normal curve, and then inverses, compositions of functions, and that's about it. So today we'll do this sequence and series and variations. Now, because so much of what we do with sequence and series is really based on these formulas, that we have formula sheets primarily for that. There's not much else on this that we use. So I'm going to hand these out just so you're looking at these. Take that, pass them back. Just said it's a formula. Go. You're welcome. Alrighty. So remember that what a sequence is, right? It's an ordered list of numbers, meaning it's a list of numbers, and order is important. If I have 1, 2, 3, 4, that's a different list of numbers than 4, 3, 2, 1. Right? Order is important in a sequence. Right? And the series, what we call a series, is the sum of a sequence. So the series here would be 1 plus 2 plus 3 plus 4. So just basic definitions. Right? I mean, if you want to see everything we did on sequence and series, go back, watch the videos on that, because they're all there. I'm just going to try to review a little bit of these concepts. Right, so we had two kinds of sequences that we dealt with, arithmetic, geometric. Right, what was it that told us that a sequence was arithmetic? Meaning, it looks like you keep adding the same thing to get the next term, right? In this case, what number does it look like you're adding? 4, right? So this is the difference, 4, 4, 4, and this here, this is a formula for the nth term in the sequence, also known as an explicit formula, a sub n. And this is, and it's on your formula sheet, right? The first, under the column of arithmetic, the first formula, that's the explicit formula for the nth term of an arithmetic sequence. Okay. Now, what does the A1 represent? The first term. What does the D represent? This common difference right there. And what does the N represent? The number, I always call it the ordinal number of the term, like the 10th number, the 20th, right? So that's what you're going to plug in. If you want A20, put N equals 20. What does the dot, dot, dot mean at the end of that? What do you call that? It's got a word. Well, you know, we've used it in here. There you go, infinite. Okay. Oh boy. Okay. What is it that makes this geometric? Yeah, it looks like you're multiplying by the same number to get the next term. In this case, it's 3, 3, 3, dot, dot, dot. And then here's the formula for the nth term, a sub n. And again, that's an infinite. What's the word if it's not infinite? And you have to pronounce it right. Josh. Finite. Finite. Okay. Here's the formula for the nth term, the explicit formula for the nth term of a geometric sequence. Okay, the A1 again represents the first term. The R is common ratio, right? And that is this one right here. And the N is the ordinal number of the term you're trying to find. Notice that for an arithmetic sequence, the formula for the nth term, it kind of looks linear, mx plus b, right? That's how you know that you're dealing with arithmetic. And you notice that what would be, if this were mx plus b, if it were, the m is the common difference, right? It's the slope of that 4 right there, that's the common difference, right? In this formula, it does not look linear. What kind of function does that look like? It looks like it's exponential, right? And you notice that the common ratio, that's what's being raised to the power n minus 1, or whatever's being raised to the power, that's the common ratio. Okay. So write the formula for this sequence. Is it arithmetic or geometric? It looks like, yeah. So how do you check? You subtract. And what do you subtract? Do I subtract 3 minus 18? No, you subtract the second term minus the first term, right? And then the third minus the second, and the fourth minus the third. If they're all the same, then you got arithmetic, right? It's always they say the difference of consecutive terms, but it's second minus the first, right? This is 15, 15, 15. So again, what does the 15 represent? Common difference, which is D, right? So if we're going to write the explicit formula, then I'm going to write down AN equals A1 plus N minus 1 times D. And then I'm going to have to fill in for the A1 and the D. So what is the A1? 3, you can see it right there. So that's AN equals 3 plus N minus 1 times 15. And then we should simplify. Distribute. What is it? 3 plus 15n minus 15, combine like terms. Okay, so 15n minus 12. Okay, so that's the formula. Okay, find the 32nd term. How would you use that formula to find the 32nd term? Plug in it, the n equals 32. So A32 equals 15 times 32 minus 12, which is what? John? 468? Okay. Are we good with that? Matt? You good? Sure? Okay, how about this one? Arithmetic or geometric? Geometric. What does it look like you're multiplying to get the next term? It looks like it's a 2, right? So this is, again, you got to do 10 over 5, right? Equals 20 over 10 equals 40 over 20 equals 2, and that's R. Okay, so all we need to plug in now is those two things. The first term is 5, right? The R is 2 to the n minus 1. Okay, should I simplify? There's nothing to simplify. You cannot multiply 5 times 2, right? Does not work because the 5 is not being raised to a power, so you just leave it like that. Now find the 10th term. A10 equals 5 times 2 to the 10 minus 1, which is 5 times 2 to the 9th. 2560. Does Sandy agree with that? Okay. Ready? Okay, so series. Series is when you add up the sequence, and it could be arithmetic and it could be geometric, right? This is the arithmetic. So if you have if you look at the dot, dot, dot there, that looks like it could be an infinite arithmetic series. When you get an n equals 15, that's actually called the nth partial sum. That means add up the first 15 terms. You can only add up a finite number of terms with an arithmetic sequence or series, right? So the formula, which you have on the sheet, right, is S sub n, right? That's finite. Sn equals n over 2 times a1 plus an. Okay. What does the a1 is first term? We know that. The n is the number of terms. What does the an represent? It's the last term, right? So that is the last term. Well, if you're looking at this, on the left, you don't know what the last term is. So how would you know what to plug in for A sub n? I mean, you either use the formula for A sub n, the one we just used on the last example, or you've got another formula at the bottom, which you don't need the last term. All you need is D. But, you know, you could tell the D anyway, so that's actually a pretty easy fix. Just use this formula. Sn equals n over 2 times 2a1 plus n minus 1 times d. Right, so now we need to know number of terms, we know. First term, we know. Common difference, we know everything. So if I had to do this one here, I would definitely be going to the last one in the left-hand column. S15 equals 15 over 2 times 3 plus, see ya, 15 minus 1 times, and the common difference, 4. So you could number crunch all of that, and what do you get? Yep. Is there a reason for that? No, I mean, a lot of times, you know, as you have like parentheses inside of parentheses, the inner ones are simple parentheses, and they just get more complicated as you go out. So we're leaving. Good luck. Sure, it's worth it. Okay, so what is this? 15 over 2. 6 plus 14 times 4, which is 56. What is that? 465. So again, if you had this and you could actually see the last term, then by all means you could plug it in. Now, if you were given this, but you weren't given that, then you'd have to do something to figure out how many terms that's supposed to be, right? And how would you figure out which term or how many terms there are if the first term is 3, the common difference is 4, and the last term is 59? Use the A sub n formula, right? And then you would figure out, okay, n is 15. So you plug in 15, 3, 59. And you're going to get the same answer either way. So just make sure, you know, you got both of those on the form. So know what they're for and when to use them. Okay, find the sum of that one. Go ahead and do it. Use whichever formula you think is correct. Find the sum. Who are they coming for this time? Done. Josh, you can answer. What'd you get? 710. Let's see. Does Lee agree with that? I won't even ask Sandy. That's probably a sensitive subject. How many agree with 710 and Josh? Me too. That's correct. Right. So you would have used this one. S20 equals 20 over 2 times 2 times 7 plus, and I'm just going to do the n minus 1, 19 times 3. 710. Done. Okay, good to go. Oh, sorry, Nat. Actually, it was at this point when we were learning this stuff that we introduced that summation notation too. So that's another thing we should look at. I'm trying to see, did I already have that in there? No. So we'll do it next. I mean, the summation, if I wanted to write this as a summation, it would look like this. N equals 1 to 20, right? That'll give me 20 terms. And then here, I need the formula for the nth term in the sequence. And what would be the formula for the nth term? You know it's going to be, it's arithmetic, right? So it's going to be something that looks like mx plus b. And you know that the common difference is like the slope. So it's definitely going to be something like 3n, right? And in this case, when I did 3n, 3 times 1, I ended up getting a 7. And 3 times 2, I ended up getting a 10. So what must I be adding here? 4. 3 times 1 plus 4 is 7. 3 times 2 is 6 plus 4 is 10, right? So that looks like the right formula. Okay. So this one, if you were presented with this and you wanted to use your formula, n over 2 times a1 plus an. I mean, I need 3 things. The number of terms, the first term, and the last term. How many terms are there? Incorrect. If it starts counting at 3 and it ends at 10, how many is that? It's not 7, it's 8, right? I mean, just think on the last, it's very clear here that there's 20 terms, but 20 minus 1 is 19. You got to add 1 at the end, right? It's like you got to add 1 for the end point to make sure you got both endpoints, right? So this one here, how many terms are there? 10 minus 3, 7, plus 1, 8. So we would have to say 8 terms. And then how are you going to find the first term in this sequence? Plug in the lower limit here, right? So you plug that in to get A1. And how do you get AN, the last term? Plug in the upper limit right there, AN. In this case, it would be 2 times 3 minus 6 is 0. And 2 times 10 is 20 minus 6 is 14. Right, so S8 equals 4 times 14, which is 56. Okay, now this is a place that the calculator might help you out. How can we use the calculator? We have a summation in the calculator, right? So make sure, where do you find that? Alpha window is one way. You only need one way to get there, but you can find it in the math menu. You can find it at alpha window, right? Alpha window is handy because there's 3 things in there that you might use. You might use absolute value, summation, or log base. All of those are there, right? So if you want to use the summation, hit the 2. And now I'm just going to use X. You could use N. If you want to use N, you just have to use the alpha keys then to get it. But I'll use X, starting at 3, and then I arrow up to the top, and I get 10. And then I've got to put the entire formula now inside those parentheses. So 2x minus 6. And then get out of that. There we go. The sum from 3 to 10 of 2x minus 6, 56. Okay? No, you wouldn't have to. If you're given something in a summation notation form, you can put it in there. Did you see that? Alpha window. Look at that. Number 2. Alpha window 2. Right. If you go to the math menu and scroll to the bottom, there's summation right there. So actually you can find log base and summation. And if you go arrow to the num, you get the absolute value. And what else in that list do we use? The I part, right? That's the other part. Okay. Now for geometric, we have another formula. Sn equals A1 times 1 minus R to the N over 1 minus R. Okay, so we need to plug in the A1 and the R and the N. In this problem, the A1 is 2, that's easy. The N is 10, that's given, right? You just have to figure out what's the R. What is the R? It looks like the R is 3, right? This is the same sequence that we used before. So S10 equals first term of 2 times 1 minus 3 to the 10th over 1 minus 3. And that's the place where we could end up having trouble. If there's one place, you know, this one is sometimes the mistake gets made. You've got everything right there, but you end up not getting the right thing in the calculator, especially if R is negative, meaning that these are switching signs. You might have, there's more of a chance that with a minus in between here, and then you're subtracting a negative, you know, that you could have some confusion with that. I just said, the way I like to do these, which is probably one step more than most want to do, is I would actually, with my calculator, store, I just use A for A1, A is 2, R is 3, N is 10. And then I type in the formula right there, just like it is. And it'll take care of all the order of operations, the possibility that signs might, you know, minus and negative, things like that. It'll take care of all of that. Okay. Now, what's the difference between that problem and this problem? Okay, which means what kind of a series is it? Just a sec. Good. So infinite. So can you add up this infinite geometric series? Why not? Because it's infinite? No, because there actually are times when you can add up an infinite geometric series. Right? Look at your formula sheets. Right? You have a formula for infinite. It's the last one under geometric. And what's the condition to the right of the formula? Right. You need to have the absolute value of R is less than 1, meaning the terms got to be getting smaller. If they're getting bigger, it's not going to add up. It's not going to converge because every time you add one more term, you just change the sum, right? So this one has no sum because we've looked at this one. The R is 3. That's definitely not less than 1, right? So that's a non-starter. Now, what if it's 58, 18, 6, and 2, right? I switch the order. What does that make the R in this case? No. 1/3, right? Not -3. Holy moly. Right? So 18 over 54 equals 6 over 18 equals 2 over 6 equals 1/3. That's R. So definitely that's less than 1. So you can use this formula, right? This is less than 1. So we can use the formula S, and on this here, is the only place I've ever seen it written that way. It's S infinity, right? Equals A1 divided by 1 minus R. So you just have two things to plug in, A1 and R. A1 is right there, 54. R is 1/3. So it's 54 divided by 2/3, which is 54 times 3/2, right? Flip and multiply, which is 81. Right? 2 goes into 54, 27. 27 times 3 is 81. Now, could you use the calculator to do that? Well, let's see. let me, if we were going to do this, if I write this as a summation, it would look like this. The sum n equals 1 to infinity of the first term is 54, the r is 1/3, and then raised to the n minus 1, right? Well, that's just, how would we enter a summation, an infinite sum in the calculator? So let me say I'm going to go to my summation. This time I'm going to go math 0, right? And I'm going to put x equals 1 on the bottom. There is no infinity symbol. So what are you going to pick? What are you going to put on the top? What do you say? Why 127? Because the main thing is just don't make it ridiculously big, you know, because the calculator sits here and thinks and thinks and thinks. So you don't want to do that. So we have to put 127. I guess I'll put 127. I don't think that'll cause too much trouble. Now, here's where this becomes important. You're looking at that formula there. Yeah. Okay. If you're looking at that formula and you think that these parentheses are these parentheses, they're not, right? This whole formula has to go inside there, the whole formula, right? So there's going to be two sets of parentheses here. So let's see, that'll be 54 times, now I'm going to use, how do I find the fraction? Alpha y equals 1. And now I'm going to make that a 1/3. And I'm going to raise that to the, sorry, yeah, I guess that's right. Yeah, that'll work. X minus 1. And get out of that. Get out. So the whole thing has got to be inside. And now when I hit enter, hopefully it'll work. See it thinking? 81. So just, you can do an infinite sum, just to, you know, pick a big number. If you pick a number and it doesn't like give you a nice whole number, pick a little bit bigger number. See whether it'll round it off to something fixed. Okay. Okay, how about this one? Could you do this sum? It's an infinite sum. What is the value of r? R is 3. It's greater than 1. No sum. Does not converge. No sum. Right? Greater than 1. No sum. Okay, could you do that one? Yes, we already did. Right? Could you do that one? The terms are getting bigger. They're alternating signs, but remember, that's an absolute value. What about that n equals 10? It's finite. It's finite. You can always add up a finite sum, right? Just use this formula there, the a1 times 1 minus r to the n over 1 minus r, right? And how about if it was an infinite sum? No, because why? Because the terms are getting bigger, right? If the terms are getting bigger, there is no infinite sum. And again, could you do that? Yeah, because it doesn't have an infinity. That might look like an infinity, but that's probably because you've got your head on the desk. So, you know, pick up your head. It's supposed to be a joke, right? If you had your head on the desk, that 8 would look like an infinity. Okay. Okay. And now it's laying down. Okay. Okay, we don't have time for all that. So let's review variations now, right? We had 3 specific kinds of variations. Okay, quiet please, we're almost done. See, Jessica's got her head down. That probably looked like an infinity to her. Okay, here's the direct, here's inverse, and here's joint. Right? What do they all have in common? K. What do you call K? It's the constant of variation. They might even call it the constant of proportionality, right? And they can even say, like sometimes they'll say, y varies directly as x, or they might say y is proportional to x, right? In the same way, they mean the same thing. So notice in a direct variation, because y and x are on the same level here, if x gets bigger, then y gets bigger. If x gets smaller, then y gets smaller. In the inverse, because x is in the denominator, if the denominator gets bigger, the fraction gets smaller, so y is smaller. If the denominator gets smaller, then y gets bigger. They vary in different ways, right? Inversely. The joint variation is like a direct variation with a product, right? Z varies jointly with xy. I mean, you could say directly with the product of xy. Combinations could be any kind of combination of those things. You know, Z varies directly with x and inversely with the square of y, right? Z varies directly, when I write varies, I'm doing the K right at the moment I'm saying the word. And then directly with x and inversely with the square of y. I mean, you could make up literally infinitely many combinations of these things. You just have, as long as you know what these mean right here, you should be in good shape. So this is an example of the kind of problem you get. It might be more of a word problem on it. You know, it might be the pressure varies inversely with volume and directly with temperature, something like that. But this is without the word problem. Z varies directly as the square of x. So the first part of all these problems, they tell you what kind of variation it is, and you got to write it down. How would I write down that Z varies directly with the square of x? Z equals kx squared. Okay, that's part one, right? Part two, they got to give you a point where you know the values of the variables so you can solve for the k. And they do, right? Z is 45 when x equals 3. So plug that in so you can solve for the k. 45 equals k times 3 squared. So 45 equals 9k. So k equals 5. So once you find the k, you update your variation. It's actually z equals 5x squared. And then you get to the third part of the question, which is answer a question. You know, find z when x is 6. How will you do that? Just plug in x equals 6. Z equals 5 times 6 squared equals 6 squared is 36. 5 times 36 is 180. We're good? Good for that. We're good. So the homework is these are the variations, and these are arithmetic sequence and geometric sequence and arithmetic series and geometric series, like 2 problems of each.